Hello, and welcome to another episode of Problem Solving with Miss Jones. I chose this problem because it's something that comes up a lot over and over again, and it's a good skill to practice. So I just made up this problem here with three masses on an XY axis, and there's two questions. What is the gravitational potential energy of the system? And what if we put a 0.01 kilogram particle here? What would be the magnitude and direction of the gravitational force? So first, we'll do part A. And the equation for gravitational potential energy is UG equals negative G M1 M2 all over D. All right, now remember, this one is not squared, it's just D. And we're going to have to add up the gravitational potential between all the particles. So between these two particles, and these two particles. So we're going to need to do a little bit of trig, or a Pythagorean theorem, to find this distance here, but it'll be the same as this distance here. So I'm going to go ahead and do that. If we do a squared plus b squared equals c squared, we find that this distance here is 1.12 meters. Right, you can check that with the Pythagorean theorem. So we're just going to add up all of these energies. UG equals negative G times 2 times 5. I'm going to start with these two. These two first. All over 1.12. Now we'll do these two. So it's plus negative G times 5 times 3 all over 1.12. And then one more, these last two, G times 2 times 3 all over 1. It's 0.5 plus 0.5. G is our gravitational constant. Oops, I forgot my negative sign here. 6.67 times 10 to the negative 11. So I'm going to go ahead and do that calculation. I suggest you do the same. All right, so when you do all this math, you end up with negative 1.89, and this is energy, so it's just going to be joules. Okay, for the gravitational force, we're going to find the gravitational force on a particle that's 0.01 kilograms, and we're going to have to find the force between all of these particles and add them up like we add things that are in different directions. Now these are all attractive forces, so it's going to be attracted to this one, we'll call that F1. It's going to be attracted to this one, we'll call that F2. And it's going to be attracted to this one, we'll call that F3. And all of these forces, F equals GM1 M2 over D squared, or R squared. I don't know what your book uses. Okay, we're also going to need to take into account the direction. So these two are both in the X direction. So I'll do sum of the forces in the X direction, and we'll see what that net force is going to be. So that's, we'll do F2 to the right minus F1 to the left. So F2 will be G times 3 times 0.01 all over 0.5 squared minus the force to the left, which is G times 2 times 0.01 all over 0.5 squared. And I'm going to pause a minute to do that calculation. All right, I'm back. I did this calculation here, and I got 2.668 times 10 to the negative 12 newtons in the X direction, and that's going to be to the right because it's positive. If this one would have been bigger, we would have gotten a negative number, which means it's to the left, and that makes sense because the bigger mass is here on the right. And then we just need to figure out what the force is in the y direction. So this is our Fx. Force in the y direction will just be the attractive force between these two. So that's just going to be g times 5 times 0.01 all over 1 squared. I'm going to pause to do that calculation. All right, when you look at the force in the y direction, I got 3.335 times 10 to the negative 12 newtons. All right, and that's going to be upward. So this is where students forget to add these together properly. We can't just add them together because they're in different directions. So we need to add them like you add perpendicular vectors. So we have Fx 2.668 times 10 to the negative 12 newtons to the right, and 3.335 times 10 to the negative 12 newtons up. And our final answer will be the hypotenuse of that triangle, and we'll also need to find this angle. I chose this angle because when we draw the triangle, we started here, and I went to the right, and then I went up. So you always want the angle near where you started drawing your triangle. So to do that, we're going to do the Pythagorean theorem. C is going to equal the square root of our Fx squared plus our Fy squared. Okay, when you do the Pythagorean theorem, you should get 4.27 times 10 to the negative 12 newtons. And the last thing we need to do is find the angle. I'm going to do the tangent, opposite over adjacent. So the tangent of theta equals 3.335 times 10 to the negative 12 over 2.668 times 10 to the negative 12. You can do the inverse tangent to solve for theta. So theta equals, I have theta equals 51.3 degrees. You can say above the positive x-axis. All right, this whole process here is going to really come in handy, so make sure that you know how to do this. If you want more practice, let me know. Thank you.